Hi guys, welcome back. We are continuing lesson 2.2 today about graphing systems of inequalities. And hopefully you understood the last lesson and you're feeling good about that. And we are going to jump in right where we left off. So the first question I want to kind of start you guys out with is based on what we did last time, and it's number 9 on page 24. Okay. So number 9, part A says, what part of your graph represents solutions for which Roy would have no money left over? Explain. And B says, what part of your graphs represents solutions for which Roy would have some money left over? Explain. So again, and I'll go back to our graph from last time. What do you guys think? Where would Roy have no money left over? So thinking about he spends exactly how much that $13.60 that he has. Okay, and hopefully for that you answered the boundary line. All right, so that is the spot where he's going to spend exactly $13.60. So the boundary line, any solution on there would be where he's going to have no money left over. He spends all of his money from his winnings. Okay. And then obviously what part of your graph represents solutions for which he would have money left over is below that. So that shaded region that we did below the boundary line, that is where he will have some money left over. Okay, cool. Here's a solid math tip that we kind of talked about already, but greater than or equal to or less than or equal to have solid lines, and less than or greater than have dotted or dashed lines. Cool. Constraints, we talked a little bit about that last time, but constraints are conditions or inequalities that limit a situation. Okay, so here we are. Roy is going to realize that there are some other conditions or constraints that apply. So we're looking at number 11, and it says write an inequality for each constraint described below. Okay, so A says Roy eats lunch and dinner on the first day. On the remaining 4 days, Roy eats at least one meal each day, but never eats more than 3 meals each day. Okay, so let's think about this. We've got day 1, where Roy eats for sure lunch and dinner, so 2 meals. And then we've got day 2, on the remaining 4 days, he's going to eat 1 through 3. So, or 1 to 3. So let's say days 2 through 4, 2 through 5. He can eat anywhere from 1 to 3. We're not sure. Okay, so let's think about that. We know that the least amount he could eat would be 2 plus, let's say he just eats 1 meal the other 4 days. So that's the very least amount that he would eat. And that's going to be 2, 3, 4, 5, 6. And then the most amount that he would eat would still be 2 on the first day. But let's say he eats 3 the rest of the days. So 3, 3, 3, 3. So that's going to be 3, 6, 9, 12, 14. So now we have a constraint to come up with, or a condition about the meals, which remember we've been using M. Let me use a different color. We've been using M to represent meals. Okay. And we know that he can eat at most 14 and at least 6. So we can write this as 6 is less than or equal to M, and M is less than or equal to 14. So the amount of meals he eats, we don't know for sure, but we know it's somewhere between 6 and 14. All right, hopefully that makes sense to you guys there. Okay. Then part B says there are only 10 performances that Roy actually wants to see while he is in New York City, but he may not be able to attend all of them. Okay, so now we know we have a maximum of 10 performances. Okay, so we know, and again, we're talking T tickets because we're talking about the performances. And we know that he could go to all 10, so it could equal 10, but he also could go to less than 10. Okay. Now, if we want to complete this inequality, we could say that, okay, Roy is going to go to anywhere between 0 and 10 performances, right? We know he's not going to go to negative, so between 0 and 10, that's how many performances. Okay. Cool. So now we have two more constraints or inequalities that we have to deal with. I challenge you guys to try part C if you'd like, but we're going to skip that for right now. And we are going to go to part 12A, where it says to list the inequalities that we found in items 3 and 11. So item 3 was that original inequality that we found, so that 100T plus 40M is less than or equal to 1360. And then the two that we just found in number 11, so 6 is less than or equal to M, which is less than or equal to 14, the meals, and 0 is less than or equal to T, which is less than or equal to 10. Cool. So now, this is where you may want graph paper, but part B is saying graph the inequalities from items 3 and 11 on a single grid. So now we want to put them all on one grid, okay? So let's do that first one we did last time. So we know that there was a point here at 34 for the meals and 13.6 for the tickets. And remember, we just connected those with a straight line, okay? And now, for right now, because we're putting 3 inequalities on the same grid, I'm just going to show which way this should be shaded, okay? And I'm not going to actually shade everything just yet, okay? All right, so we have that in red. Then let's do this meal one in blue, okay? And, okay, our meals are like our y-axis. So we know these are going to have to be horizontal lines. And how we graph this is actually just a horizontal line. Whoops, let's undo that. A horizontal line at 6 and a horizontal line at 14. Okay. And now I know you could test a point here to see where to shade, but we can also just say, okay, well, M has to fall between 6 and 14. So we should shade between these two lines that we just drew. Okay, and again, I'm just doing arrows for right now because eventually we're going to see where this combined or this overlapped shaded region is. All right, so then let's do this last one in green. And this one is our T values. So this one has to be vertical lines at 0 and at 10. So this is going to go right here. Oops, sorry, can't draw a straight line. And this is going to go here. Okay, and again, T has to fall somewhere between 0 and 10. Whoops. So I would go like this and shade this way in between. Okay, so now I know it's kind of hard to see, and if you wanted to, you could lightly shade each of these and see which is the darkest section, but what is the section of overlapped? Okay, so what section is shaded by all 3 of these inequalities? Okay, and so what we're going to do here is take a look, and it's going to be this weird little section right here. This is the part that would be overlapped and shaded by all 3 inequalities. Okay. All right, cool. So now we can use this because we have all three inequalities. We can use this to answer some questions on the next page. So I'm going to kind of be going back and forth. If you have your graph on graph paper, I would keep that next to you. Okay. So 13 says, by looking at your graph, identify two ordered pairs that are feasible options to all of the inequalities. Confirm that these ordered pairs satisfy the inequalities listed in item 12. So in order to be feasible, it has to fall within that overlapped shaded region, or what I have in purple, okay? So we can just pick any two random points like 4, 8, and 6, 12. Sure, both of those fall within there, so those could be our points. And when it says to check, what you could do is plug each of these in, and remember as TM, so plugging, in this case, 4 in for tickets and 8 in for meals. You could plug that into each of the inequalities and just make sure it makes it true. So for example, you would just plug them into all three of these and they should make all three true. Okay, cool. All right, then 14 says label the point 6, 10 on the grid in item 6. And that's item 6 is all the way back here. And if we go to 6, 10, we're labeling that right there. Okay, and so interpret the meaning of this point. Okay, so what exactly does this mean in the context of this? And remember that it's an ordered pair is in TM. So this means Roy will purchase 6 tickets and 10 meals. Cool. All right. Is this ordered pair in the solution region common to all of the inequalities? All right, so now let's check it out on this new graph that we have with 3 inequalities. And it is 6, 10. So yeah, that falls right within the purple. So we would say that yes, it does meet all of our restrictions or constraints and inequalities. Okay. All right, and then the last one we're going to do for today is 15. It says, if Roy uses his prize money to purchase 6 tickets and eat 10 meals, how much money will he have left over for other expenses? Show your work. Okay, so now we're just going to take that and we're going to plug it back in to that 100T plus 40M. And so 6 tickets, let's plug that in there. And 10 meals, let's plug that in there. 100 times 6 is going to be 600, and 40 times 10 is going to be 400. So if we add those together, he's spending $1,000. Okay, well, remember he had $1,360. So if we subtract that 1,000, he would still have $360 left over for other expenses. Cool. So big thing is that we understand coming up with these constraints here, and we know how to graph them and shade an overlapped region. And we know that solutions should be in that overlapped shaded region. Okay. Awesome. If you have any questions, let me know. Thanks. Have a good one.